This video is all about reminding you to remove parallel earth paths when testing for AM2 and AM2S. We've got a three-phase supply, we've got our three cut-out fuses, our neutral and earth are linked together. Our earthing arrangement for this system is TNCS. Removing parallel earth paths for your true value of external earth fault loop impedance, in this case, would require us to remove the left-hand conductor and test between that disconnected conductor and L1, L2 and L3 and record the highest reading. There is a link on this one, special MET, where you could remove the link, because on the right-hand side you have a conductor going to the bonded steel framework of the building and the other one goes into the distribution board. I'm going to show you at the very end of this presentation how Matt carried out his external earth fault loop impedance test where he didn't have an MET, but it's likely you will have an MET at AM2 or AM2S. So it's about removing the parallel path and testing the true value of the external earth fault loop impedance. To do that, you'll need to disconnect, in this case, the conductor on the left-hand side and test between that disconnected, removing the parallel earth paths, and L1, L2 and L3, and recording that reading as the highest one of those readings as your true value for ZE, external earth fault loop impedance. I'll show you in a minute some drawings of how this would happen before Matt shows you the physical test, but it's the MET that's important. Look at your installation. If you have an MET, you need to remove those parallel earth paths when carrying out safely your external earth fault loop impedance test. So let's break down what we could have at AM2, AM2S, AM2E. Main supply on the left-hand side, TNCS, TNS earthing arrangement, whatever it is. And we've got an MET now. In the video I'm going to show you at the end of this one, Matt didn't have an MET. He had all the bonding conductors and the earthing conductor within the distribution board. We can see there, metallic water, metallic gas, it might be metallic structure of the building, offering parallel earth paths. So removing the earthing conductor within the distribution board wouldn't remove those parallel earth paths. So you're going to have to remove it from somewhere else before doing our external earth fault loop impedance. Exactly the same rules apply: turn off the supply, notify people, and all the other stuff that we have to do, but it's removing those parallel earth paths I want to concentrate on in this video. So what we've got now is we've zoomed in to the MET, the main earthing terminal, and you can see there the bottom conductor coming in from the left-hand side brings the earth in from the supply source, and a single earthing conductor then into the distribution board, and our bonding conductors are on the right-hand side, in this case going off to gas and water that are metallic incoming, therefore offering a parallel earth path because they'll be connected to the greater mass of earth being a metallic water pipe and a metallic gas pipe. So you have to remove those parallel earth paths for a true ZE reading. To do that, you disconnect the 16mm, whatever size it is, earthing conductor as I've shown there, which is the incoming one from the main supply. With that disconnected, remembering the board needs to be isolated, etc. before disconnecting it, we can now test from the disconnected earthing conductor, possibly 16mm or greater, to the board itself's individual lines to get our true external earth fault loop impedance. By removing it from the MET, you remove the parallel earth paths created by the metallic water, gas, structure of the building, etc. Let's see that test. I've connected onto my disconnected earthing conductor an L1, and I would perform my earth fault loop impedance test and remember the reading. I would then move it on to L2 and repeat the test again. Remember, this is at the bottom of the main switch with the board isolated, so it's the only live part within the board. And I would remember that reading. So I would test between the earthing conductor, L2, as an external earth fault loop impedance, remember the reading, before I move on and test L3. L3 now, my disconnected earthing conductor are tested, and I remember the highest of those three readings, and the highest reading would be recorded as my ZE value, my external earth fault loop impedance of this distribution board. And you note all parallel earth paths are removed because the earthing conductor was removed from the MET. We're now going to watch Matt perform the external earth fault loop impedance test on a three-phase distribution board where the earthing conductor and bonding were all within the distribution board, but remember to look at your AM2 or AM2S rig to see if there was an MET there, a main earthing terminal. If there was, you're going to need to perform the test as I've just described. It's a real treat for the channel. We're back out with big sexy Matt O'Dell, and we're going to try today to go through some of those tests that are going to be required for AM2 and AM2S. And which one are you going to pick out first that we're going to have a go at?
So in particular, we've got the three-phase board.
Yeah.
So we can do the earth fault loop impedance,
yes,
the external earth fault loop impedance, and then the PFC.
Yeah, so they're really crucial for AM2S, AM2, and well, if AM2E, if you're doing the experience route as well. And we're going to make sure that we don't miss out a part, especially now we've got a three-phase board, because often at colleges they're working on single-phase installations, aren't they?
Yes, yeah. So it's a three-phase experience that maybe our learners don't always get the hands-on experience with.
Yeah, so we've got permission in order to isolate the supply here, and we're going to go through it in the correct process, which means we're going to knock off first of all the breakers before doing the main switch. We're going to remove the cover, and then we're going to show first of all external earth fault loop impedance and then prospective fault current.
Yes.
Okay, so you can knock some breakers off then for me, Matty.
Okay, and so we've got the single-phase breakers here, so we'll start turning those off. And so you can start seeing some lights go off.
Yeah, I'll just show that because we're working in the world's most terriblest place, aren't we, today? Look at that. Okay, so yeah, whips them off.
So just do the single phase. So the lighting's just gone off in here. Do you want them to stay on just for now?
No, we'll turn everything off. We'll do it properly.
And so then we've got our three-phase breakers. So that's a blower, a compressor,
okay,
a three-phase supply to another board there, to the office board.
We've turned off a lot of the local loads as well, so we're not actually got loads of stuff on full load on for the breakers, and then obviously we can do the...
And so that looks like all the loads have been taken off.
Yeah, and we're going to do the main switch, are we now?
So now it's quite happy just to turn the main switch off.
Okay, so we're going to get the cover off and we'll look at doing these tests Matt described at the start of the video.
Okay.
So the board's off, the cover's off, and we're now going to carry out the external earth fault looping pin. Just remind me why I'm going to disconnect the earthing conductor, which is here.
Okay, so yeah, so it is the main earthing conductor. So if we was not to disconnect it, then we'd be having a problem with parallel earth paths via sort of like the extraneous conductive parts through the bonding and stuff like that. So we want to know the external earth fault loop impedance, and so by removing this earth, that is just the external, nothing internal. Okay,
and we've got an earthing range, as I said, of TNCS.
Yes. Yeah,
so what's the maximum reading for that for the external?
On a PME or TNCS, it's 0.35 ohms.
Okay. Okay, so earthing conductor's out. We're just going to drop this off.
Right, so yeah, we've got the earth out.
Still care, because obviously the bottom side of this is live.
It is live.
There is no remote isolator here. You might find in AM2, AM2S, there might be another isolator that you can actually turn this off before removing it, but we're in the real world here. So they're now live at the bottom of that switch.
They are, yeah.
And it's red, yellow, blue, and not brown, black, grey. And we're going to set up our instrument now in order to carry out that external earth fault loop impedance. So we've set our Mega MFT 1730 up to LPE, and you're going to do it on the 3-lead low, and that's what you've selected to do it on. We could have done it on high because there's no RCDs, but you think that this will probably be the standard practice to get used to, Matt, is that right? When we've got so many RCDs around that we go for the low setting, is that okay?
Yes, yeah.
Right, okay, do you want to probe on for me so we can see the...
Okay, so we've got the exposed disconnected earth there, so we'll get a nice good connection onto there. And then we've got the neutral terminal here,
yep.
And then we've got our 3 phases there. So let's just move that one out of the way. So again, it's an automatic test. So go onto the neutral terminal first, and then we'll just probe onto the first line conductor. And as you can see there, the machine is automatically detected voltage, and it takes a few seconds.
Because we're on the low one, yep, that's fine.
Yeah.
So we'll persevere and wait for our result.
So as you can see there,
0.08. So that's it. We're finished. Pack up. We're ready to go. Is that right, Matt?
No. So that's on one of the phases. So obviously there's 3 phases. So we'll just repeat that same process on the next phase. Okay. So again, because we're going between neutral and the phase, it's detecting a single phase voltage. So I think it's about 240 volts in here.
Of the 3 readings we take, which one are we going to record?
So it's just the highest reading.
Okay, so we've got to remember we've got 0.08, now we've got 0.09, so that's now the highest one.
And then we'll probe back on. If you notice, every time I physically
take your probes back off in the right order.
Take them
exactly
off,
the same as we do for obviously supply polarity and safe isolation. Yeah, right, 0.08 of an ohm. So we've carried out the external earth fault loop impedance test there. We've got 3 readings. You said you're going to record the highest one in your test paperwork.
Yeah.
Okay, we'll remove the earthing conductor. Just remind me again why we removed that.
So purely for parallel earth paths, we want the external earth fault loop impedance, and
Yeah.
so that is the external earth that goes back to the supply transformer.
Good.
So that is the one that has to be removed.